Hello, AP Statistics students. Sorry I can't be with you today, but we still have a little bit to do. If you haven't done your quiz yet, go do your quiz. It's a couple questions, and then you can come back to this video and watch today's new stuff. All right? So, welcome back. Hopefully you did your quiz. Today we're going to do a full confidence interval and all the ways that you show your work for the confidence interval. It's a 4-step plan here. It's called state, plan, do, conclude. All right. On a free response question, if you're ever going to do a confidence interval, you have to do these 4 steps. And no, it will not tell you to do state, plan, do, conclude. You need to know to do these 4 steps. So what are these 4 steps? The first is state. Communication is important. That's why we start with state. We state what we are going to do. All right? We're going to create a confidence interval kind of thing. But you do it precisely and with context. Then your plan. All right? So a big issue with statistics is, are you allowed to do statistics? So you declare your procedure that you're going to do, and then you check these conditions, these assumptions that show that you are actually allowed to do this math. Basically, you're proving that you're not doing BS. All right? Then you do the math. That's pretty easy. We did that part yesterday, so hopefully doing the confidence interval math is no big deal. And then you conclude, you interpret your answer again in context. So let's do one of these, and so you can see the 4-part procedure here. So a recent poll of 738 randomly selected cell phone users found that 170 of them admitted to walking into something or someone while talking on their cell phone. Admit it, you've done it, you know you have. All right? Construct and interpret a 95% confidence interval for the proportion of all cell phone users who would admit to walking into something or someone while talking on their cell phone. All right? So, first, we have to state what we are going to do. We will create a 95% confidence interval for the true proportion of cell phone users that would admit to running into something. All right, so we said what we're going to do. We're going to create a 95% confidence interval for the true proportion. Okay? All right, now the plan. We're going to do a 1 sample z interval for p. That's what this is technically called. A 1 sample, because we took 1 sample, z interval. All right, we're using z stars. We'll use something different later, but right now it's a 1 sample z interval for a proportion for p. Now, in order to do this, there's some conditions that have to be met so that we can prove that we are in fact not doing BS. The first is a random condition. Did this data come from a random sample? All right. And yes, we come up here, a recent poll of 738 randomly selected cell phone users. Check. We have to, though, specifically point that out. Okay. Let me unbold here. This condition is met because we have a random sample of 738 cell phone users. Now, why do we have to have this condition? This condition allows us to apply our findings to the entire population. All right, at least the population that we sampled from. All right, that was a big thing when we talked about experiments versus random sampling. You are allowed to extrapolate your findings, to apply your findings to the population that you sampled from, as long as you did a random sample. That was the issue with experiments. Experiments, you aren't randomly picking people. So you can only apply your findings to people like those in your experiment. But here we actually took a random sample. And so we are allowed to apply these findings to the entire population. Next, the 10% condition. Do we meet the 10% condition? This is an assumption, but it's a pretty safe assumption. It is safe to assume that our sample of 738 is less than 10% of all cell phone users. There are definitely more than, 7,000 cell phone users, so we are definitely less than 10%. Again, we have to do this because we are sampling without replacement, right? We've done the 10% condition before. That part's not new. So it's still a thing. It allows us to use our standard deviation, remember, all right? This allows us to use our standard deviation formula, which now we are calling our standard error formula, which is the square root of p hat times q hat over n, right? Oops, make my square root bigger. There we go. But yeah, the 10% condition means that formula is valid. And then we have to take a look at our large counts condition. Okay, I'm going to do this one with my pen. So we have to check n times p hat this time. Make sure that is greater than or equal to 10. And we have to check n times q hat to make sure that is greater than or equal to 10. So we'll do 738 times, what was the proportion they got? 170 out of 738. So 170 out of 738. All right, 23%. All right, so 23% of people admitted to it. So in our sample, that's 170 people. Okay, so I know this one, 738 times 0.23, is going to be 170, which, yes, is greater than or equal to 10. And then how many people said no? 738 times q, which would be 77%, right? Okay, 77% of 738 will be 738 minus 170, right? If 170 people said yes, 568 said no, which is in fact greater than or equal to 10. You need 10 successes and 10 failures, right? So that is our large counts condition. Why is that important? Okay, because this means our or the hypothetical sampling, the sampling distribution will be approximately normal now. And all our math is based off the normal model, so our sampling distribution must be approximately normal. All right, but that's what you got to do every time. I know it seems like a lot, but you will get really fast at that, especially when I'm not talking through it. But you have to meet those three conditions in order for your math to be valid to prove that you are not doing BS. All right, but now we can calculate it. It is 0.23 plus or minus. All right, they were doing a 95% confidence interval, right? So 2 times our standard deviation, which is 0.23 times 0.77 divided by 738. So here is our confidence interval. Let's do a little bit of that math. 2 times the square root of 0.23 times 0.277 divided by 738. All right, so my margin of error is roughly 3%. So it's 0.23 plus or minus 3%. So the interval is from 0.20 to 0.26. All right, my calculations are done. Now I can write my conclusion. I am, 95% confident the interval from point 20 to point 26 contains the true proportion. All right, context time. What were we talking about again? Proportion of cell phone users that would admit to running into something. Whew. All right, there are the 4 parts. All right, again, we state what we're going to do. We plan and prove that we can actually do this math with those 3 conditions. We do our calculation, and then we write our conclusion. Those are the 4 steps to doing a confidence interval. We'll keep practicing that. Hopefully that makes some sense, but that should be enough for you to get your homework started, which is on Sapling like usual. Hopefully I'll see you tomorrow, everybody.